So welcome to our Cloud 66 webinar. Today we're going to be doing a demo on how to deploy Docker in production on bare metal using Cloud 66 and Packet. My name is Aaron Welch. I'm the head of product here at Packet. Packet is a bare metal cloud hosting provider. So dedicated servers on demand, 6 minutes or less, over an API with all of the nice trappings and tools that you would come to expect from big public cloud, only no virtualization whatsoever. Very good for production workload. And that's why we've been working with Cloud 66. That also is a great orchestration tool for Docker and is a great fit in particular for us. So today we have Vic. I'm going to hand it over to him to do a little intro now, and then we'll get rolling with the presentation. Thanks for watching.
Right. Hey, everybody. I'm Vic, CTO at Cloud 66. So I'm here to talk to you a little bit about Docker and containers on Packet. Right. I've got a little presentation. Let me get that up. There we go. Right. Docker in production on bare metal. So here's a little bit quickly about Cloud 66, what we do. We're full stack hosted container management as a service. In a world full of PaaS and IaaS and SaaS, we reckon Fushmas is the next buzzword. You heard it here first. Starting off with a bit of humor. So what do we really do? We do all this stuff on the back end so that you guys can get your cool apps up and running in Docker. You guys shouldn't really have to be worrying all that much about all the core orchestration that's going on in the back end. Quickly, a little bit on container core concepts. This isn't really a Docker 101, but if you guys have absolutely no idea about containers, some very basic things here. So containers are great because they give us immutable infrastructure. And that allows us to ensure that for a given image, we have a replicated environment across any of our hosts. So given an image, we can run that image in a variety of hosts, and we can be sure that that image is going to be the same across all those hosts. You don't have to worry about different dependencies or builds being in place on those hosts. There's a fantastic separation of concerns. So inherently with Docker, you have great separation. And that means that you can, like say, on a single host, run two conflicting versions of some framework, for argument's sake. And you don't have them overlapping with one another. It's fantastic for microservice architectures. So you can just imagine you have a bunch of hosts, you have a bunch of services, you can move those services between hosts. You can scale them independently of hosts as and when you need. And then just like a final point here. So often, Docker is synonymous with container technology, but it's worth pointing out that there are some other players in the container market. For argument's sake, Rocket, and container technology is relatively new. So, stuff is moving on and happening all the time. All right, so let's get started. So what I've done is I've created a little video, actually, which is a starting point. Let me just get on a screen share. Right, so I've recorded a video of your initial Cloud 66 experience here. The reason I've done this as a recording is, in the first place, just to set up your initial stack. We don't really want to be waiting for the stack to build. The whole process takes about 10 or 15 minutes. So, okay, so we're going to hit our initial landing page on Cloud 66 here. Welcome to Cloud 66. And you can choose to build a Docker stack, or you can build a classic stack. So we do support rack framework-based stacks, such as Rails, Sinatra, Padrino, and also, of course, Docker. So let's go into Docker here. So select to build a Docker stack. We give our stack a name. This is arbitrary. I'm going to call it simple demo. And we choose an environment for the stack. The difference between environments primarily is that development environments are free. Completely free for you. However, they are locked down in the sense of that you can't scale those environments. You can't add load balancers, for argument's sake, which you wouldn't be expecting to do in a development environment anyway. Okay, so we now want to add a Docker service. Essentially, a Docker service is a single Docker container application. So we're going to create a service called web. In this case, we've got two options that we can use to create our Docker service. We can either pull code from GitHub or from some Git source. And if that code includes a Docker file, Cloud66 will automatically build that into an image and push that image into a private repository and pull from that private repository to your service. So your whole development workflow is essentially just making changes to your code and pushing that code as normal. That's kind of the workflow that you'll probably be used to. The other alternative is to build from a Docker image, whereby you would create a Docker image, push that to some Docker image repository of your own, and you can pull from that repository down to your service. So in this case, I've created a Docker image already on key.io called Sample Rails. It's a Rails app, obviously, called Sample Rails. And I'm going to say this is accessible from the internet. So I'm going to check this box over here and say that, and tell Cloud66 that our container is running on port 3000. Okay, so do we need any additional data sources or backend services? Yes, so these are the ones we have available for you right now. For this particular stack, we need MySQL. So I'm going to select MySQL. And now I'm going to go to the advanced view. So I just want to demonstrate here that we have a basic view and we have an advanced view. The advanced view is far more powerful. There's a whole lot more stuff that you can do, but it can be a little bit daunting. So here's what we've generated automatically based on our basic view of this new stack and our single service called web. We have web, we have an image, and we have ports mapped. The ports mapping 3000 says a container runs on port 3000. 80 says that's the HTTP port that this application will be exposed on the host. And 443 is HTTPS port. So let's go and add a couple more things here that we need for this application to work. So this application is a Rails app, and it didn't have an embedded command in the Docker file in the image. So we're going to provide our own command here, which is just bundle exec rackup-p 3000. We have a build command and a deploy command. The build command is essentially any arbitrary command you supply, which we will execute on the first build of this service. So an example of that could be db migrate for Rails here, or again for Rails you could say db schema load to create a database from scratch for use. Then you have a deploy command, which is a command that will be used every time that you actually deploy this service. So in a Rails world, you want to run db migrate. The similar is for any technology. Okay, so let's go ahead, go forward there, and let's click next. So go through this phase. So we're now at the phase 2. Now we have to decide where we want these services to be deployed and how do we want them to be deployed. So you can deploy to your cloud provider or you can deploy to your own server. In the case, just for demonstration, deploying to your own server, you can select an existing server. Say you've already fired up a server on Packet and you want to control that yourself. You don't want to share API keys with anyone. You can expose port 22 to that server and provide us with a username and SSH key to get to that server, and we'll deploy to that server on your behalf. However, it's much more powerful to deploy to your server as a cloud provider. So selecting Packet from our providers there. If you deploy to your cloud provider as opposed to your own server, then because we have API keys for your cloud provider, we can do things like automatically scale up your servers on your behalf, for argument's sake, create load balancers. So when we want to select Packet there, if you haven't added Packet as a cloud provider yet, you can do so simply by clicking on the Add Another Cloud Provider button, select your Packet from the Cloud Platform list, and provide your Packet API key here. Pretty straightforward. So now we're chosen Packet, and we're going to select the server region. Here we've got Parsnip in New Jersey, and we have a server size of type 1. We have type 3 also available. We're going to choose type 1 for this demonstration. And now because I specified MySQL as a service backend, I can now decide how I want to deploy that. Do I want to deploy that locally on the same web server as our web application, or on a dedicated server? So in normal circumstances for a production application, you would want to deploy your backend services on a database servers on a dedicated server. This helps with a variety of things, but most importantly, you can scale your database server independently of your web servers, and web servers independently of your database server. Okay, so the other option there, no, I don't want to deploy MySQL, could be if you are running MySQL externally. Let's say you have a SaaS MySQL providers. All right, so we've chosen locally, and we're going to deploy. So we initiate build. We're firing up a server called Jaguar on Packet. Here we go. Preparing the server. Preparing the server is essentially a step whereby after we fired up the server, we will baseline all the packages. We'll update packages and provide all the security enhancements for those packages, depending on what the current status is, and install all the infrastructure components that are required for your application to run. Just so you know, I cheated a little bit and sped up the video, so you can see that we started at 1542 and 1551 is where we are now. So there's a bit of time has passed, 9 minutes have passed. So here you can see this point. We're pulling the Docker image from the Docker image source that we specified, key.io, down to your server. We're now going to build MySQL. It's a good point to actually mention that we don't build the database backend services as a Docker container. We found that there is limited value in doing that. Because we are building them from scratch on your servers directly, we're able to control kind of the A to Z of those servers. That means that we can have additional powers, one-click backups, for argument's sake, one-click restores, automatic replication, automatic data imports, all that kind of stuff. So here we're building Nginx, building Docker, performing a container deployment. So you'll see up at the top, next to the Docker cluster, you'll see that we are, the status is creating one container. That's one single container for our web service. And that has now started. And we're going to continue with server provisioning. And that's it, we're done. So that was the deployment of a brand new Docker stack on Packet. Let me go back to the demo now quickly. Okay. Right, so I'm actually going to now switch to a live demo, which is always fun, so bear with me. 1 second here. Okay, so let me switch to simple demo. Here we go. So this is our application that we created earlier. And you can see that the only difference is after I created that video, I went and I scaled up an additional web server. So you can see that I've created a server Panther. And the way that I did that was I simply went to my Docker cluster and I clicked on add another Docker server. So I'll show you that if I click on that now, I can select the server size, how many I want, give it a server name, and click add server. So in this case, I gave the name Panther. We're going with the cat theme, I think. Okay, but what's important here is I can see that I have one web container running on each of these servers. And I can look across the cluster and see that I have one container running on each of these servers, given a nice name. And I can drill down into any one of those containers, and I can look and I can see more information about that container, but particularly all the container runtime information, which is automatically pulled back from the container when it's started. You can see all that there. Right. Okay, so I just want to show you quickly that this application is actually running. So if I click on Browse, open that new tab, I can see it's a very basic application that just generates some random number, I believe. And I can also see that if I go to the servers individually, I can drill down right to the server and look directly on that server. I can see it's exposed on port 80. Okay. Right, so let's say that I want to now change the number of containers that I have running on each server. For argument's sake, I have a single threaded container that can only handle a single request at one time. So my scaling mechanism will be in number of containers that I'm running. So you could simply do that by coming down to either the server level or the cluster level and select to scale up the containers. So I'm going to go to Jaguar and I'm going to say, give me, clicking on the scale up button, give me 3 of these containers on this server. And I'm going to click the scale button. And it's going to go away. It's going to create additional containers on that server. We should see them start here automatically. There we go. So now we have 3 containers running on Jaguar of our service web. We can click on those containers and see them here. Right. Okay, so now let's say that for some reason we want to go and restart those containers. Some external dependency has changed, or we need to cycle them for some reason. You can also do that simply through the dashboard here. Restart services. You can restart them sequentially, one at a time, thereby ensuring that at least one container is always available to listen to requests, or concurrently if you want a faster restart and you don't mind about having downtime. Okay. So the next thing to talk about here is deployment. So I now have a cluster of Docker servers, and I have an image of web, and I want to deploy this. I've made a change to my image. I've pushed that change to my image repository, wherever that may be, in this case, key.io, and I say, let's go and deploy that. I can go to the deploy menu. I can say deploy all. I can deploy with options, or I can create a new profile. So in this case, I'll show you deploy with options. And I can see that I only have a single service, web, and I don't have any build options, and I can just publish it. And I have some additional options. So I can deploy in parallel, I can deploy in serial, I can deploy with Docker upgrades, and I can deploy security upgrades. So these things are useful for you if you want to, say, change version of Docker, if you want to upgrade or downgrade, if you want to deploy in parallel or serial. So if you deploy in serial, then it means that we will deploy to each one of your web servers, first taking it off the load balancer, adding it back to the load balancer, deploying to it, and doing that through each of your web servers, essentially ensuring that you have at least one web server always on the load balancer server. Talking about load balancers here, I actually didn't add a load balancer to this stack. However, it is very simple. You can simply click on this button, add a load balancer. This will automatically create a server on Packet, and it will configure and install HA proxy on that server, automatically passing traffic through down to your other Docker servers. So let's cancel that for right now. Okay, cool. So I'm actually going to show you a deployment quickly now. So I'm going to say deploy all. This is a single service that's going to be deployed. We're starting this deployment now. And while this starts, I'm going to show you here in the logs, you'll see everything that's happening. You can also drill down to your individual servers. So let's go and have a look at what's happening on Jaguar. So I'm drilled down to Jaguar, and I check out the logs here. And I can see that, oh, okay, so it's pulling an image, pulling the new version of the image from key.io. And what else has it done? It's updated environment variables, environment files. It's running our deploy command for web, which we defined, which is regdb migrate. It's starting a container for web. It's waiting for a successful health check from web. So it started 3 containers because we had 3 of them running. And it's received successful health check from all the containers. So it's rebuilt Nginx, and it's reconfigured Nginx, and is now serving the new version of our application. I wanted to point out here that this health check it's pretty cool, actually. So let's go and have a look at that quickly. So if I come to the stack, the base stack page, let me explain what happens. When you deploy an application, essentially what we will do is we will create new containers for that application based on the new image of that application, of that service. And only when we are sure that those containers are actually up and running will we switch over to your new containers. You can configure this using a health check. So if I go to configuration files here, and I have a look at my service YAML file, you'll remember this from the beginning. I can see this is my service, and I have here this line, health timeout 100 seconds. This is the default. This is much more powerful, actually. We allow you to specify a whole bunch of configuration settings here. The default setting will be that we will curl your container on the container endpoint and will not accept it as healthy unless it returns with a 200, with an HTTP 200. We have the same thing happening for TCP as well, and UDP coming. And it's really great because it ensures that you have true zero downtime deployments. Okay, so let me look at now a slightly more complicated stack. So this is a single stack with a single service on it. If I go and take a look at this multi-services demo, this is another stack that I prepared 15 minutes ago. And if I look at the Docker cluster, I see it's got a single server, which is shared with a database, with a MySQL and a Redis server. And I can see that it is running an API service, a log entry service, and a web service. And it's got one container of each one of those. So these are a bunch of different services on a single stack. So if I go and look at the configuration of this stack, and bearing in mind that you can change the service configuration on a given stack at any time and redeploy your stack to change the services that are being used, I can see that I have log entries, web, and API. So log entries is an image, and that's just there to pick up container logs and send them through to my log entries account. I can see that it's exposed on container 123, TCP 123. I believe that that's a test there. Looking at the web implementation, the web service, I can see that this is based now on a Git URL. This isn't a Docker image. This is a Git URL. And this Git URL contains a Git branch, Docker build grid Redis. And that branch contains code and a Docker file. And we have everything else that we had from our previous service. So we have a bundle exec passenger start. That's the start command. We have a db migrate. We also have a log folder here, which defines that the logs in our application automatically get pushed through to the host to var log container. And we can see that it's exposed on port 80. And we can see that we're mounting volumes for this now as well. So we're mounting the volume temp on our host to container temp host. And we specify that we want to restart every deployment. And we have a health check saying, come in and check, make sure that I'm healthy every time I deploy. Our API is now based on our key.io image, as before. So there's no change there. The only change that we can see is that it's now listening on 8080 and 8443, as opposed to port 80 and 443. It is possible to have multiple services listening on port 80 together. And we have a service struct called a traffic match that allows you to specify that traffic going to a specific subdomain will be routed to a specific service. So you could have, say, api.yourapplication.com going through to API, and web.yourapplication.com, or the default of yourapplication.com going to your web service. Great. So that's our services there. So if I go and show you now, in particular this, so web is using build grid. So if I go to the deployment of this application now, and I say, I don't want to deploy all, I want to deploy with options. I can see that I have all three services available. I don't want to deploy all of those. I'm just going to build and publish web. So let me run that now. So we'll see that actually going to build here, we'll see we have a build grid. Build grid represents all of the builds that are currently happening on Cloud 66 for your stacks. So I can see that this repo, this branch, and this Docker file are being used for this application. I can go and look at the log for that. So I can see this image that was created, which is done via the web by Vicar Cloud 66. And I can see that it was created with this following output. So you'll see all of your Docker file build information here. So if we go back to our application detail page, and I go and now look at my build history, I can see in our history that build was succeeded for application web. and I can see that we're currently publishing web. Looking back to the previous one, I can see we built web and we published API, log entries, and web together. You can see information about what your deployment profile was like for this build as well. Right. So it's just waiting for the health checks to complete. So something that's worth mentioning here is I have a bunch of different services now running on the single server. Those services could be moved to separate services, to separate servers. Cloud 66 provides automatic networking and routing via the use of Weave, and we manage all of your ports between your servers to ensure that all of your containers can see each other. We also provide a layer of DNS, which we call Delphi, and that is automatically updated to allow your containers to see each other and to see the system services that we've provided. So an example of this would be to have a look at, if I just move to here quickly. So on our simple demo, I have a MySQL server and I have a service called web. And from within web, I can always call mysql.cloud66.local without fear of anything going wrong. That'll automatically resolve into the IP address of the server where MySQL is running. The same is true for the actual services themselves. So let me come back here. You can see this health check is actually taking a while to succeed. I'm wondering what's going on there. I'm just going to cancel this. This is what happens when you do a live demo. All right. So let me talk about some other things here. Let me talk about environment variables. So let's look at environment variables. You can have them at a stack level. These are a bunch of environment variables which we can define. We can define our own ones here. These ones are predefined. So Redis URL is the Redis URL internal value. And Redis internal URL value is created by default by Cloud 66. So if your server's IP address changes, for argument's sake, we'll automatically change that for you. And you can define your own environment variables here at a stack level. You can also go into your service YAML and specify environment variables that you want to be available for a particular service. So over here, you can say, for service log entries, I want to add the environment variable ABC value 123, for argument's sake. Right, so now we have a stack and we have a server. How do we kind of make sure that that server is secure? Well, one of the things that we do is we lock down the server's ports to everyone. The only person who has SSH access via port to your server is Cloud 66's production servers. So that begs the question of how do you gain access to your service? Well, you can do it one of two ways. You can go into network settings here, and you can specify firewall rules. So you can open a firewall rule to an external IP address. We don't recommend doing this, though, because what tends to happen is you need access to your server. So you're in a coffee shop or something to that effect, and you go and open up a firewall rule, and then you forget to close the firewall rule, and your server is vulnerable essentially to some kind of DOS attack or hack attack. So what do? We instead we provide you a mechanism to lease a temporary SSH connection from your IP address, wherever that may be, for a certain amount of time to a port. So you can say, lease me a connection to my server for 10 minutes, and after 10 minutes, Cloud 66 will automatically close that behind you. It's much easier to use the tool belt, actually. So we have a Cloud 66 tool belt, and you can use a very simple command, cx SSH to your stack and server, and we will automatically open up a firewall port, connect you via SSH to your server, and then shut the door behind you when you're done. The tool belt is actually really powerful, and it provides access to a lot of features which aren't available in the UI, although I don't think I'm going to go into it at this point. Okay, so you can see as well in the static rules here that we've automatically created these rules inside your stack to provide you with a mechanism so you can see like your Docker cluster has access to your Redis server, for argument's sake. Okay. So I think these are kind of like the basic features that most container providers have. Perhaps we have a bit more. But there's a whole lot more stuff that we do. So I wanted to quickly run you very quickly through some additional features that we have. So if I go into one of these stacks and take a look here, I have a MySQL server. So because we've built this MySQL server ourselves, we can quite simply go and say, well, let's just go and configure replication. So I can hit a button and I can add replication from another stack source. I can do a database import. I can automatically go and import from another stack source. I can automatically create a backup. So let's just go here and say, well, I have a backup that I created when I created this stack. I guess that's habit. So I can see that I have a backup happening on the hour, and the database size is 10 kilobytes, and I can download that at any time, or I can restore that. So this is a managed backup that Cloud66 provides. It means that we are storing your backup data under a secured S3 location for your account. So we take care of all the logistics of rotating that and making sure it's available to your server and shipping those from your server to the S3 location. You can also create scheduled tasks. So this one is quite interesting with Docker. So it's very easy to create a cron job. So you can create like a server task to say, oh, I want to run a particular command on my server, select a server, Jaguar, I want to give this command a name, test, and I want to run ls-la/, right? And I want to run that on demand. Don't run it at any time except to tell you. I'm going to install the server task here. And I should be able to see it very quickly. So I can see this task and say, okay, let's go ahead and run this job. See what happens. Oh, okay, that happened. Came back very quickly, show the details. There's the result of my task. That's pretty basic stuff. You can use that obviously for more powerful scheduled tasks if you have requirements of them. However, there's something else which is quite cool within Docker. You can now create a scheduled task to run in a service against a service. So we can go to install stack add-ons and select that we want to run a service task. So let's go and install a service task. I'm going to say I want to run on the Jaguar server. I'm going to run against the service web. I'm going to say simple service test and specify some command. And I'm going to say, again, you can run it every few minutes, every hour. You specify your own cron string. I'm going to say run on demand. So let's install this service task. You can also see the results of your previous runs of your tasks here. So let's go into this service task and say, let's run this job now. So this is actually going to get to your server, and it's going to open up a container of the service that you've specified and run the command against that container. This is quite useful because oftentimes you want to run some application framework specific task, and you need access to the application or framework that's in the image. Okay, you can also very easily add an SSL certificate to your application, to your site. You can do SSL termination, which is automatic. Which means that we terminate on your load balancer if it's present, as opposed to terminating an Nginx on your servers. However, it's again configurable. It's up to you. If you want to, let's say that you have some specific requirement for your Nginx configuration, or for your HA proxy configuration, or for your database configuration. We actually expose those to you via something we call custom config. So if I go down to my Docker cluster, I can actually click on Configure Nginx at this point, and I can see the Nginx config that is actually being applied to my servers. This template is actually available in a custom Git repo that Cloud66 has created and maintains for me. That means that I can use my standard development tools to modify these files, to merge any conflicts that might exist, and simply push them. I can also see Git history via standard Git tooling. It uses a templating language called Liquid, and is pretty powerful. You can essentially change whatever you want for your stack. You can then go and preview that change and push that to your application. When you commit it to your server, we're going to go and update your Nginx configuration in this case, and restart Nginx. We'll reload Nginx. Right. Another thing that's available is for common workflows. You make a change, commit your code. It goes through to some CI, some continuous integration. Potentially that's local, potentially that's a hosted service. And at the end of that, we provide you with a way to automate the deployment of your stack. So you have something called a deploy hook, a redeployment hook. So if I go and look at my stack settings and information, I can see that I have a redeployment hook over here from the stack. And I can use that from within one of my services to deploy this stack. And that's really powerful. And if the service includes in its payload the Git hash from which continuous integration was run, then we'll actually go and pull out that particular Git hash. We won't just get head from your branch. We have a bunch of other really useful add-ins here. So let's say that you want to store a whole lot of data. One of the things with cloud computing is that you're relatively limited on disk sizes. So we have GlusterFS, which allows you to essentially create a NAS spanning a bunch of cloud servers. This allows you to go beyond the storage allowance that you have on a given server. You can also use it for redundant data backups. So it replicates data across multiple hosts for additional security of that data. And we also provide, there's the standard add-ins. So SSL was database backups we talked about. Log entries is an integration with log entries. We just automatically install the log entries agents and configure that for your logs. Okay, so if I go back to the main page here. And the last thing I'm going to talk about, second last thing actually, I'm going to talk about here is the failover process. So we have simple demo here that's running in production, and that's going great. And something happens that there's a problem with our application for some reason. Maybe there's an outage in an area, or an external dependency is not available, and we need to move to another stack. We provide a simple mechanism. So I've created in advance the simple demo backup of production. And you can use something called a failover group, which is essentially a construct which binds multiple stacks together. I can see that I created this failover group, and it's currently pointing at simple demo production. And I can, using this simple toggle here, I can switch it to point at my other backup stack, my simple demo backup. By doing that, I'll automatically switch the DNS traffic of this endpoint to point at the head DNS endpoint that we create for the backup stack. Obviously, your data needs to be taken care of. So we have replication, and we recommend that you would have replication going from your demo to your backup stack, from your primary to your backup stack in this case. And then the last thing that I wanted to quickly show you is live logs. So oftentimes debugging containers can be quite interesting. It's another level of abstraction on top of on top of standard application debugging. We can use the CX toolbox to attach to a container if you want to get onto the server, and you can actually go and run commands in the container's space. However, by the UI, simply you can click on live logs, and live logs creates a tunnel from your application to Cloud 66 and pushes the logs through to us. There's no persistence of these logs, so it's only live. So if I go and look at, just make sure that I have the right server here. So let's say I'm going to start just listening to everything on the server, and I go and open up the web page. I'm going to see some logs coming through. If I go down right to the bottom of this guy and I refresh this a couple of times, I see that there's a bunch more logs that have come through. This is quite powerful, especially when you're trying to debug an issue that's happening in production. But you can see here that all the logs are intermingled because they're from multiple sources. So what you can do is you can either use a filter. So let's say I want to filter down to all GET requests. That's going to just automatically filter down the data I have. Or let's say I want to look for greetings.js, any requests for greetings.js. If I throw that in the filter, that's going to show me all of the log lines for that. And I can see that I have some from a development log, which is a log file, and I have some from resource source humorous panda, which is a container, and from Frank Plucky Turtle, which is another container. So, and those two containers are obviously logging independently of, depending on the application that you're running inside it. I can click on the context to get more context about a particular log line, which is really useful as well. So I think that's kind of like a real whirlwind tour of Cloud 66 feature. There's a whole lot more stuff going on, particularly around Active Protect for file monitoring on your servers, and probably too much to dig into right now. So let me hand back to let me go back to this demo quickly. And there we go. So thank you from us. It's me, Vic at cloud66.com, and seeing us towards the end of the year. Season's greetings to everyone. And thank you. Aaron, let me hand back to you here.
Yeah, sounds great. That was great. Yeah, if folks have questions, yeah, feel free to get in touch with Vic at his email, which was vic@cloud66. And then if you have questions about Packet, you can reach me at welch@packet.net. And likewise, happy holidays to everybody. Thanks for joining. And we'll be posting this to the YouTube channel and then probably posting a summary in a blog later in this week. So if you missed something or you want to review it, you'll be able to do that shortly. Thanks again. And thanks again to Vic and Kasia at Cloud 66. And we'll talk to you soon. Bye.